You ever find yourself in a situation where you need to create an object in your code, but it's a real pain to build? Maybe it needs a network call, a database query, or just some super complicated setup. What if, instead of building it from scratch every single time, you could just point to an existing one and say, hey, give me an exact copy of you? Well, that's precisely the idea behind the prototype design pattern. It's all about making the perfect copy.
So, here's our game plan. We're going to start with a super common coding mistake that I like to call the assignment trap. Then, we'll use a fantastic analogy from Excel to really get a feel for this. After we formally define the pattern, we'll dig into the most critical detail, the difference between a shallow and a deep copy. We'll also check out a cool way to manage our prototypes with a registry, and then we'll wrap it all up with why this pattern is such a game changer.
All right, first things first, let's talk about the very problem that the prototype pattern was born to solve. And it all starts with something we've all done, assuming a simple equal sign is actually making a copy of something. It's not, and it can get you into some serious trouble. Okay, look at the code on the left. This is the trap. When you say obj2 equals obj1, you're not making a copy. No way. You're just slapping a new label onto the exact same object in your computer's memory. So if you change something in obj2, you're also changing obj1 without even realizing it. That's how you get those head-scratching bugs that take hours to track down. What we really want is what's on the right. We want to clone the object. This creates a brand new, totally separate copy. Now you can mess with obj2 all day long and obj1 remains untouched. That independence, that's our goal.
To really wrap our heads around what a prototype is, let's just forget about code for a second. Let's talk about something we've all used a million times, a spreadsheet.
So, picture a single cell in Excel. That right there, that's our original object. It's our perfectly set up prototype that we want to duplicate.
And we don't just put some data in it. We give it a specific state. We make the text bold, and we tell Excel, hey, the data in here is a date. All that formatting, all that metadata, that's part of our object's state.
And here comes the magic moment. We hit copy, that universal command that basically means, I want another one of these, exactly like this.
And when you paste it, what happens? You get a new cell that is a perfect clone. The text is bold, the date format is there, everything is preserved. But, and this is the whole point, it's completely independent. You can change the date in that new cell, and the original one doesn't even flinch. That's it. That's exactly what the prototype pattern is trying to do, create a perfect, state-preserved, yet totally independent copy.
All right, with that Excel analogy fresh in our minds, let's put a formal name and definition to this really slick idea.
You know, at its core, the prototype pattern is just what it sounds like. It's a way to create new objects by, well, copying an existing one. Instead of going through some complicated creation process, you just find an object that's already set up the way you want, and you ask it to clone itself. Simple as that.
So when would you actually pull this out of your toolkit? Well, 3 scenarios really stand out. First, when making an object from scratch is just plain slow. It needs a database hit or a network call. Cloning is almost always way, way faster. Second, it's great for decoupling your code. The part of your program that needs an object doesn't have to know its specific class. It just has to know that it can be cloned. And third, if you have objects with a ton of different configurations, instead of making a crazy number of subclasses, you can just set up a few pre-configured prototypes and copy them whenever you need one.
Okay, we've come to what is honestly the most crucial technical detail of this whole pattern. You have to understand this part. Because when you say clone, it turns out not all copies are created equal. There are 2 very, very different ways this can go down.
First up, we have the shallow copy. Imagine you have a car object, and inside that car, there's a GPS object. With a shallow copy, you get a new car, sure, but that new car points to the exact same GPS system as the original car. So if you update the destination in car B's GPS, it mysteriously changes in car A too. That's because only the car itself was copied. The objects inside it are still being shared. It's quick, but man, it can lead to some really weird bugs.
Now, a deep copy. This is usually what you actually want. When you deep copy car A, you don't just get a new car B. That car B also gets its own brand spanking new GPSB object. Everything, all the way down, gets duplicated. The 2 cars are now completely and totally independent, just like our Excel cells were. It's safer, it's more predictable, and while it might be a tiny bit slower, it saves you a world of headaches.
So if you're going to have all these cool prototype objects, where do you keep them? Well, there's a really elegant pattern for that too. Instead of just having them scattered all over your code, you can centralize them in what's called a prototype registry. Think of it like a vending machine for your objects.
Yeah, it's exactly what it sounds like. It's basically a catalog, or a library, that holds a collection of your fully configured, ready-to-go objects. Each one is stored under a simple name, just waiting to be copied.
And using it is incredibly simple. It's a three-step process. First, when your application starts up, you create your prototypes, say a standard two-wheeler and a four-wheeler, and you register them. Then later on, when some part of your code needs a new vehicle, it just goes to the registry and asks, hey, can I get a four-wheeler? And finally, the registry finds the original prototype, tells it to clone itself, and then hands that fresh new copy back to your code. It's super clean and keeps everything nicely separated.
So let's bring this all home. After going through all of that, why should you care? Why should you add this pattern to your mental toolbox?
It really boils down to three huge benefits. Number one, performance. When setting up an object is slow, cloning an existing one is a massive speed boost. Number two, decoupling. Your code gets so much cleaner because it doesn't need to know the specific class names of the objects it's creating. And number three, flexibility. You can actually change how your app behaves on the fly just by adding new prototypes to the registry, often without even having to recompile anything.
And there you have it, the prototype pattern. It's elegant, it's powerful, and I guarantee it's used in more places than you'd think. Which kind of leaves me with one last question for you to chew on. Think about the software you use every single day. That template in your word processor? A character preset in a video game? Where else are these clever little prototypes hiding in plain sight?